I lean forward, so I'm going to be sitting about here like this. Okay, this is Joe's voice on this side of the aisle. Okay, I appreciate that. I sound more like Jono.
For people who love science, this is Equinox, where we're striking the balance between the light and the dark. This is episode 2. I am Joseph Darnell, and I'm joined by Dr. Robert Carter, your friend and mine. Hi, Rob.
Hey, Joe.
So for this one, we're going to get to one of the other interesting topics that we've had in the outline we've discussed in advance, something that's near and dear to your interests.
Yeah.
And we're going to get to that in a minute, but we had a couple of side notes for the show. One of them being that we just worked on our music and our sound effects, and you're going to have that in episode 1, but I'm really happy with how they turned out.
Yeah, it was kind of fun hearing the bings and the whistles and the things like that as you added them for effect. I like that.
I always liked chimes more than music at the top of shows. I've done a lot of podcasts where I try to put a musical theme into the beginning of the show, and it's just hard to find something that you want to hear for all the episodes moving forward.
Yeah, and we've reviewed a lot of different potential intro theme songs. We didn't like any of them.
Yeah. If you want to find the show, Rob, we are now on Twitter. We have a Gmail address, which we'll hand out sparingly. You can still get a hold of you on Facebook on Biblical Genetics, correct?
Yes.
And it's primarily where you do a lot of your things on the side and where you're going to announce your YouTube channel.
Yes, Biblical Genetics on Facebook, but also I've got a Twitter handle that I just started called Bible Genetics. I don't know who owns Biblical Genetics out there, but Bible Genetics is me, and I'm probably popping up here and there as I learn how to Twitter. I've never actually been on Twitter.
So is anyone using Bible Genetics, or is it just like parked on?
I don't know.
Oh, okay.
I don't know anything about Twitter.
Okay,
Maybe I'll go find this guy and twist his arm and say, hey, can I have that handle?
All right, so all my friends out there on Twitter, please show Rob a warm welcome on Twitter. We are also working on the website. If you didn't understand what is going on, I previously had a podcast network I started with another friend and podcaster TJ Draper. So Equinox as a podcast doesn't have its own website. You cannot go to equinoxpodcast.com to get to the show. If you want to find us online away from your subscription, the website is nightowl.fm/equinox.
Simple enough.
In the future, there may be other shows on Night Owl, and I'd really like the way that the website works. We worked on that website for 2 years, and then TJ and I got turned away and distracted with other projects and life events, so we are just trying to get back to it.
It's beautiful. I love the way it looks. So if you're out there and you want a place to host, you can contact Joe, right?
Well, for friends and family and, beyond.
Okay.
In the future, we'll see where it goes.
Right.
Also, typically we'll have new episodes out on Wednesdays. We get a chance to record a couple of days earlier, edit them, and get them out on Wednesdays. Does this sound good to you, Rob?
Fine with me.
And I like it too because in keeping with the theme of Equinox, we're going to put the episode out. If I can, I'm going to schedule it to be the very middle of the week.
Oh, I like that. I like that.
Assuming you're on Eastern time.
So the middle of the week would be noon on Wednesday?
Yeah, I think so.
Exactly.
Yeah. All right, well, then I think that wraps it up for everything else. Rob, let's get to the main subject.
Ooh, yeah.
We wrapped up everything about gravity in a nice, pretty bow.
Okay.
Now we're moving on to geocentrism.
Yes.
Rob, tell me all about geocentrism.
Well, this is actually a fascinating idea. It's just the thought that the Earth is the center of the universe and everything revolves around the Earth.
Well, it is, right?
Actually, the universe orbits around the tip of my nose. We call it the heliocentric model.
That is why I'm so magnetically attracted to you.
Anyway, no, so just the thought that everything goes around the Earth. And if you're standing on the Earth, it looks like everything goes around us. It is by far the most common idea in ancient times up through the Middle Ages. And it's one of those things that took us a couple of centuries to undo. It took a lot of experimenting, a lot of scientific work, a lot of debate, a lot of arguing, but it's indisputable now.
It's really strange to consider that a lot of people believed that Earth was the center of the universe when we grew up with very different knowledge and information, education today.
It's hard to put yourself in someone else's shoes.
But for thousands of years to think that nobody had figured it out, BC, before the time of Christ, Did people think that the universe revolved around the world? I mean, that was generally what people thought.
Yeah. Just over the centuries, they got to the point where it said, this can't be true, but how does it work? And that's what took them a long time to figure out.
It's probably why we have expressions like the sun rose and the sun set. Sounds like the earth is at the center of the universe and everything is revolving around us. But if you think about it, it's also kind of funny to picture the idea that the earth is in suspended animation and everything is going around us. What was it? I read somewhere that it would be like everything beyond Uranus in the solar system would be traveling faster than light speed.
Faster than the speed of light to go in a circle and get back to where it started.
Not to mention things
hours.
outside of the Milky Way galaxy.
Yeah.
But nobody even was aware of that until more recent centuries.
So if geocentrism is true, we just have to throw out all the physics.
So on the heels of gravity, geocentrism, or what do we call what we do know to be true today? It's not geocentrism, where the Earth is just moving around in the Milky Way.
It's a geokinetic, that means Earth moves, gravitational model.
It doesn't roll off the tongue like geocentrism.
No, it doesn't. But some people say heliocentric.
Oh.
But it's not heliocentric. The sun is not the center of anything. It's not even the center of the solar system.
No?
Because Jupiter is large enough that it actually moves the sun off of its center point. And if all the big planets are lined up on one side, the sun moves more than the diameter of the sun. So it's not the center. It's not heliocentric. It's gravitation.
So in the grand scheme of things, did they figure out gravity first and then they started to break down geocentrism right afterward?
No, there's a man named Copernicus who predates Galileo, predates Newton. In fact, I've been to his hometown in Turin, Poland, and there's a monument to him. And in Latin it says, Copernicus, the man who stopped the sun and moved the world. Amazing. In fact, he was supported by the Pope in his day. So 80 years later or so, I'm not sure exactly what the dates are because I kind of forget them, but decades later, Galileo is tangling with the Pope and he gets put under house arrest. But the prior Pope supported the work that led directly to ideas of that the Earth moves.
Huh.
So it's a very complex, very fun historical subject to study out.
Well, see, that's the thing is I don't think anybody today is thinking about religious culture when they think about science. There's almost a separation of church and science, so nobody would be thinking about the Catholic Church in modern day. I mean, they were being funded by the church. The scientists were being funded by the church. That's something else that I've taken an interest in, and some of my friends have had another podcast where they went into how the church funded a lot of the innovation in the arts in the last 2,000 years.
Yeah, innovations in arts and science and knowledge and learning. I mean, especially the Catholic Church prior to the Protestant Reformation.
It's not unusual in history is what I'm getting at.
Yeah, it's not. It's not. But the Catholic Church specifically, they on purpose pursued a lot of scientific endeavors, specifically in astronomy. There's, of course, religious reasons for this. One of them is they needed a calendar that worked. Especially when they went worldwide, they had to have everyone celebrating Easter on the same day. And that was a massive problem. A massive problem. It took them forever to figure out. And so one thing they did is they turned a lot of cathedrals into observatories. And they tracked the shadow or a bright spot of the sun on the floor in these observatories over years and years and years.
That was something you mentioned in episode 1 that I was wondering about.
But this data collection is what led us to the point where all of a sudden the Earth can move. Because a geostationary system didn't fit with the numbers. Something to point out here, though, also really important. We are Protestants. We work for an outwardly Protestant organization. We're not Catholic. But I don't hate Catholics.
Oh, of course not.
And I'm not going to call them horrible people or anything wrong just because I'm not in that denomination. But in history, it's very clear no one was ever burned at the stake for scientific views.
Okay. When we say burned at the stake, we're talking about
executed. They weren't ever put to death or even tortured over scientific views.
Which is something I remember learning in school when I was young. At least I'm a little bit rusty, but I remember hearing examples where there was some persecution over the ideas of, well, let's say even Christopher Columbus making claims that the Earth was round and everybody disagreeing with him. I mean, that is related to scientific theory. He believes the Earth is round, and then others are saying, no, it's not. And that was why it was hard for him to get funding, to get ships, to get a backing from a nation to support him,
and
from
it's
the royalty.
One giant urban myth.
Which I think a lot more of us are aware of nowadays since the internet.
Guess so, if people are paying attention. I mean, it's even Bugs Bunny cartoons.
Yeah.
It's everywhere. There's this idea, which really pretty much comes to us from Washington Irving, I think he's America's first novelist, famous American author way back, 1800s. And he writes this extremely popular novel about Christopher Columbus. And he has that scene in there where the church people are saying the earth is flat and Columbus is saying the earth is round. And as far as I know, that's where that comes from. And it's simply not true.
So who were some of the scientists in the centuries past that were sponsored by the church, besides Galileo?
I can't say necessarily every one of them, but a lot of them. Because a lot of the science is done in monasteries. I mean, okay, Mendel, who laid down the laws of genetics, he did this in his monastery garden. It's not like the Pope was giving him money, but he's doing all this work, and the monastery is allowing him to do this, and he's codifying all these new ideas about genetics, and boom, at his pea plant garden in a monastery in Europe, we get the laws of modern genetics.
Wow, okay.
Yeah, so. But something happened in history, and that was the Protestant Reformation.
In about what time era?
Well, we just had the 500th anniversary of Martin Luther in 2015, right?
It's amazing to consider how much of this is relatively recent history. We got thousands of years of history, but so how long ago was the Protestant Reformation?
Martin Luther famously nailed his 95 Theses to the door of Wittenberg Cathedral in 1517. That was 500 years ago. And that ignited a gigantic movement across continental Europe. Now, there's a lot of movement before that also. And,
Well, everybody would assume you're talking about a religious movement.
yeah, religious movement. But with this religious movement also came a way of thinking. The Protestants demanded logical progression of thought. If these two things conflict, one of them's wrong. Can't have mutually exclusive ideas. They're very scholarly, not like Catholics weren't scholarly either, but they're very scholarly. And they had this approach to Scripture as if the Bible is true. If you read the Bible describes a God. Well, describe this God. He's got all these qualities, and he never does anything against his own nature. So if that God had created the universe, he would have created a universe, that operated according to law, because he's the lawgiver. Scientific law must be true, and they go out and they discover all these scientific laws. Now, that's a very horribly brief summation. We have articles on this on creation.com. We'll put them in the show notes. Some really good documentary background behind what I just said, very briefly. But this thing is launched called the Protestant Reformation. And all of a sudden, people are like, well, let's go out and discover these things. So we had people like Copernicus, who was Catholic, and then Tycho Brahe, who was Catholic. And Tycho Brahe is collecting all this data of stars all year long, where the stars are positioned in the sky.
Which had been going on for more than 100 years before his time.
Oh, yeah. This old stuff, but he's actually cataloging in great detail and very high precision. And then Kepler gets his data and keeps on doing more stuff. And Kepler's the guy who figured out that the planets actually orbit in ellipses around the sun, not circles around the sun, like some other people had said earlier, Copernicus had said earlier. So it's an amazing idea, but there's precedence to this. I mean, we've got
Precedence to what?
precedence to thinking that.
That everything has to be reasonable and rational and logical.
Yeah, and that comes to us through a lot of scholarship before that.
Well, you think about medicine, a lot of people had a lot of superstition and common misinformation leading up to things like the bubonic plague.
Yeah, and a lot of our medicine was based on a guy named Galen, who was a Roman physician. He's completely wrong on multiple things, but everyone held him up as the authority. But he held back medical progress for 1,500 years.
A lot of misinformation was going around for the empire, political, superstitious, religious. That went on for several centuries. Faulty ideas like your emperor was God, that people believed and allowed him to get away with carte blanche. And then if there was ever anything reminiscent of a dark age, I want to say it was the centuries leading into the collapse of the empire before
The Roman Empire.
That's more or less what I would call the Dark Ages.
So way back in like the 700s, there's a famous guy named Bede. He's an Anglo-Saxon scholar. He knew the earth was round. He said even the earth is round, not like a shield, like a ball.
Right.
That's clear. But we also had people like, I can't pronounce his name, Boethius, Boethius. That's my best impression of this guy's name. In the 400s, In 400 AD, he knew that the earth was a point, a tiny little speck compared to the size of the heavens. And he said that the astronomers of his day agreed with him. So that's pretty shocking. These are not people who are thinking this is tiny or like the earth is a thing with a dome over it. And that's it. And that's the extent of it, like some of the modern flat earthers think. No, he's thinking that the universes are massive and huge and go on for a long, 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 long way. And you get people like Cardinal Nicholas of Cusa in the 1400s. He said, and this is the 1400s, now, is a quote and it's a translation, but he says, it has already become evident to us that the earth is indeed moved, even though we do not perceive this to be the case.
It's interesting he's thinking that it's being moved, not necessarily that it moves on its own.
Yes. Oh, okay, that's a good point. But
or at least maybe that might be lost in translation if he meant something else.
Possibly. But what he's talking about is that the earth orbits the sun, not the sun orbits the earth. This is 1400 AD.
Did they know at the time that other planets were orbiting the sun as well? I mean, was he making this call just about the earth or about the solar system?
I don't know enough, but I'm going to guess it's just the earth because the planets are weird. I mean, Mars does a do-si-do and goes backwards sometimes. Now, it's perfectly explainable because...
Oh, wait, yeah. How do you explain that?
We're both orbiting the sun, and when we catch up to Mars and pass it, it goes backwards.
Oh, until we get around the other side of the sun.
Not totally around the other side of the sun, but as we get past it, and then, because we're orbiting faster than it is, we pass Mars, it goes backwards. And then when we get past it again, it starts trailing along behind us and slowly losing ground. So it does a little loop-de-loop.
Yeah, okay.
And that's just bizarre.
Yeah.
That took a while to figure that out. But we know that at least by the 1400s, at least one guy, and he's a cardinal. Right? Cardinals are the guys who become popes, right? So he's second rank in the Catholic Church, and he says the earth moves, but he also talked about what we in modern times call frames of reference. You're talking in the last episode about, you're in a car and you throw a ball up and it lands right in your hand again.
Right.
Well, the ball's moving at 60 miles an hour, and so are you. In your frame of reference, the ball's not moving, it's just going up and down. But if you threw the ball out the window and hit someone in the side of the head, it's going to hit him at 60 miles an hour.
Right.
Because he's in a different frame of reference. He's not moving, and you are. So, but this guy understood that. I was introduced to this in college at Georgia Tech, and I had a hard time understanding it.
You had a hard time understanding the frame of reference?
Yeah, because we were talking about Einstein at that point.
Oh.
In Georgia Tech physics, we went into Einstein, relativity, frames of reference, and like, what on earth? And it took me a couple days to think through before, okay, I get it now.
So what was Einstein's example?
Well, when you talk about Einstein, you're talking about things moving at, 3/4 the speed of light. And you're on a spaceship and you throw a ball up in the air and you catch it. Okay, no problem.
What was his reference? Lighting a candle, turning on a torch?
All those things, yeah. Flashlight in space. You go to the bathroom on a spaceship and you turn the light on, and someone outside the spaceship sees the light coming through the window. What color is it? Those kind of questions. Yeah. So anyway, this gets really crazy really fast. But 1400s at least, they were thinking. They were building a foundation that we needed to understand how the world works.
So what was the key to unlocking geocentrism? And when did that take place?
The key to unlocking it was data. The data that was accumulated for several centuries.
Well before Wikipedia.
Well before Wikipedia, yes. And it ends up in the hands of a Protestant named Johann Kepler. And Kepler's looking at this and he says, you know what? All the planets go around the sun. The moon goes around the earth, and the moon and the earth together go around the sun. And they travel in ellipses. And he comes up with what are called the 3 laws of planetary motion. 1619.
So that's well into the Protestant Reformation.
It is, yes, well into the Protestant Reformation. But there's no physics behind it yet. He just had this idea, and he said, the math says this.
Really?
Yeah.
Mathematics, not science per se.
Well, observational data from science, right? Guys looking at stars and measuring their angle through the seasons. He said the math says this, but he didn't know why. That took Newton, and Newton came 80 years later. His 3 laws of motion and his law of gravity all of a sudden explained Kepler's 3 laws of motion. And in between there's a guy named Cassini. We had a famous Cassini probe that got sent to one of the outer planets not too long ago. He figured out that the sun changes distance through the seasons. When I was in physics in high school, we went outside 4 times, and everyone had a little card with a tiny little hole in it. And we held it up to another card and put it on a meter stick and slid it up and down until the image of the sun was exactly 1 centimeter. Well, throughout the seasons, the distance you had to move that thing with the hole in it changed because we changed our distance to the sun. And so Cassini could do that with his primitive technologies back in 1655 or something like that. And boom. Well, if the sun changes distance through the seasons, it's a pretty good indication that something's moving.
That is really hard to fathom, that you could understand that the sun is getting nearer and farther. That was another thing that I remember learning in earth science class, was that they were able to figure out the light speed by just a few degrees of data.
Yeah.
I don't understand how that happened.
And they figured out light speed back in like the 1600s.
But how do you do this without modern technology, without computers, without computerized telescopes? How do you do that?
Well, first you need to know how far away the Earth is from the sun. And that took a very, very famous mariner called Cook. He sailed around the world and died, before he got home. England sent him to Tahiti specifically to measure the transit of Venus across the sun. And if it was not a cloudy day, and he did it wasn't cloudy, and he watched Venus go across the sun, and he timed it.
Wait a minute, but why Tahiti?
Why? Because they could do the same thing in England. And then they had a triangle. They had England and Tahiti, and both of them are measuring distances, or they're measuring the time of Venus going across the sun, and they did a triangle, Venus, Sun, Earth, 2 points on Earth, and they figured out how far away the sun is. This is 1700s. And you just using trigonometry.
Oh, just trigonometry.
Just high school trigonometry. Stuff that we all learned in 8th, 9th, or 10th grade. It's big numbers, but it worked. And once you knew how far away the sun is, you knew how far away everything else was. You knew how big the solar system was. It's really cool. And that led to light speed calculations, all sorts of things like that. But even at this point, even now, we've got Kepler's laws of planetary motion. We have Newton's law of gravity. We have the sun moves. We have how far away the sun is. But we still couldn't prove that the Earth moves around the sun.
So we're talking about the colonial era of America.
Yeah.
And they still hadn't figured this out. It's amazing that this country, in its infancy, while they were still figuring this out.
The evidence that the Earth moves wasn't in our hands until after the Napoleonic Wars. So after the War of 1812, it was 1838. A guy named Frederick Bessel.
That was far too recent.
Yeah.
It doesn't feel like this should have happened recently.
Everyone knew the Earth moved, just no one could prove it. And what they needed was something called parallax. If the Earth moves, the stars should wiggle. If we really are that far away from the sun, 93 million miles, as we orbit the sun between summer and winter, we're 186 million miles apart during, at the opposite ends of the year. So if you look at a star from way over here and look at the same star from way over here 6 months later, the star should move a little bit. Just like if you hold your finger out at the end of your hand and you close one eye and open one eye alternately, your finger wiggles back and forth a little bit because of the distance between your eyes. Well, if you've got 186 million miles, you know what? There should be a lot of wiggling in the heavens, unless the stars are really, really far away.
Okay, well then how did they figure that out?
Well, he measured a star called, I think it was 61 Cygni. It's about 10 light years away, and it wiggled 0.00009 degrees.
Okay, but this is the kind of thing I never understood when this was brought up. How did he know that minute level of detail of movement in 1838? I don't get it. I couldn't gauge that today. I don't even know if I could use my phone to cipher that today.
Okay, here's how you do it. You take a big telescope. Now, this is before photography, though. Ooh-wee. So he had to actually draw things on pieces of paper.
This was before contact lenses and laser surgery?
Yeah. But you take a big telescope and you point it at a cluster of stars. And you draw a picture of them in the fall, and you draw a picture of them in the spring, or whatever it is, 6 months apart. And if those stars aren't in the same exact configuration, something's moving.
Oh.
And if one of the stars is closer, it might wiggle and the background stars won't. And that's what he found. He found this one star. There's stars in the same field that are much farther away, but are too far to move. And there's one star that's in the front of all these other stars, close, only 10 light years away. It actually would wiggle through the seasons, demonstrating for the first time parallax. And the only way to explain that was that if the Earth moved.
Wow, okay. That is genius.
So the Europeans have a satellite out right now. I think it's called Gaia. And they're measuring thousands of parallax movements throughout the seasons. And it's amazing. It's absolutely amazing. We actually have a 3D map of all the stars close to us in the galaxy.
I take all this stuff for granted because I have seen it on the internet, but I didn't realize how they came about that information.
And how hard it was to come about all this information. Now, you mentioned a little bit ago that if things are going around the Earth, they got to move really fast to get back to where they started in 24 hours. And the moon would be whipping. We would actually never have been able to get a rocket ship to the moon because nothing could move that fast. Nothing we have ever built has ever moved as fast as the moon would have to move. Forget that. You go out to, Saturn.
Oh,
It's
forget it.
so much further away than the moon is, moving so fast. But then you get to Uranus, and it's literally, it would have to travel faster than the speed of light, get back to where it started in 24 hours. And anything beyond that would have to move even faster. And remember, we can use high school mathematics to show how far away these things are.
Yeah.
We know how far away the planets are.
Okay, so this makes me wonder. You said last time that there is something of a debate, a little geocentrism debate.
There's a modern, small geocentric movement.
Why? And for who are these people?
Okay,
What?
I don't want to insult anybody,
Well, I don't either.
but it's mainly being driven by, it's not all Catholics, but it's mainly being driven by a group of Catholics who are kind of resisting the whole Protestant Reformation thing and the discoveries of all this other science. And
So it's like they're going back before the Protestant discoveries to more their earlier Catholic roots.
yeah, and it's, I don't want, I'm trying not to insult anybody, but
There's a lot of variables, obviously.
most
It's
of
not
this-
everybody is unified on this in the Catholicism.
no, not at all. It's
Yeah.
a very, very minor position.
I would almost say, well, I want to say they're probably not speaking for Catholicism as a whole.
They're definitely not.
Yeah, well, so, yeah.
Okay. But there was a model back in the day after Kepler said, okay, everything goes around the sun. Well, they said, no. Yeah, they go around the sun, but the sun still goes around the Earth. And-
So they were thinking both were...
The Earth is fixed in place,
Okay.
and the sun goes around the Earth, and all the other planets go around the sun too, fine. They just, everything together all goes around the Earth.
Oh, that'd be a
It was a
mess.
hybrid model.
Yeah.
And the problem was that the math supported it. So you can put a center of reference anywhere you want. Engineers talk about a bug on a rotor when they're talking about motors. You could draw a model where you're on the moon and everything's going around you, or on the Earth, or on Saturn, or on the sun. It doesn't matter. You can do a transformation and make everything go around whatever you want. But that's only observational. The physics tells us this is impossible. Because, and what are you going to reject? Light speed? You're going to reject the laws of motion? You have to reject physics in order to have the Earth at the center of the universe. Because, Uranus has mass. If it has mass, it can't travel at light speed. We can accelerate things here on Earth. It takes more and more and more energy to get them faster and faster and faster. By the time you're going 99.9999% the speed of light, it would probably take all the energy on Earth to move something that fast. And we can't get any faster than that because there's not enough energy.
But something that I've heard in recent years is that as they are mapping out the universe, they kind of sort of think that the Milky Way galaxy and Earth is relatively speaking near the center of the universe. Or is that a misnomer?
There's some ideas in the creationist circles, which are fascinating and amazing, that suggest that the Milky Way, maybe our solar system, is close to the center of mass distribution of the universe. Not that we're stuck in the middle necessarily, but close to the center of mass.
Does any of the geocentric debate kind of piggyback on that theory?
Not really, because these ideas come from Einstein. They're actually taking Big Bang theory and standing on its head. Because one of the assumptions of the Big Bang model, is that the universe has no edge. Either it goes on forever or occurs back on itself. It doesn't matter. It has no edge. But if it does have an edge, and if we're near the middle of all the mass in the universe, our clocks tick slower than the clocks on the edge of the universe.
Why is that?
Because gravity slows down time. That's what Einstein said, and we have abundant observational evidence to suggest that. I mean, atomic clocks at the National Bureau of Standards in Colorado tick faster than atomic clocks at sea level. When they launched the GPS satellites, we know how high they were going to go. They actually put a fudge factor in there before they even launched them. He said, we have to subtract a billionth of a second every so often. And if they weren't doing that from day one, our GPS systems wouldn't work. So we know gravity distorts time. And one of the creationist ideas is that there's an edge to the universe. Therefore, how old the universe is might depend upon where you are in the universe. And if we're near the middle, we're younger than anything on the edge because their clocks go faster. And then you add an expansion component to it, and you get accelerated. That'd be another subject for another day. It's a whole lot of fun.
So would you sound like a crazy person if back before the time of Jesus Christ, you thought that everything revolved around the sun? You know, like were there other theories that were tossed around? And did geocentrism ever get really challenged by somebody before the more recent scientists?
I'm certain there was some ancient scientist or philosopher who suggested it, but I'm going to say that geocentrism was by far the dominant idea. In fact, it might have been ubiquitous in major cultures. Flat Earth was not.
Why did you bring in flat Earth?
Because a lot of flat earthers try to piggyback on the geocentrism idea, and they like steal Bible verses and things like that, and there's no evidence of flat Earth. Some maybe of the Mesopotamian civilizations might have believed the Earth is flat, but most civilizations did not.
So what is the connection? What would they be? How would they be related? I'm thinking that everything in the universe is revolving around an object. That object could be oval, circular, something like that. But flat Earth, it's how does that work? It like the way they describe three-dimensional space. It's like it's very irrational. I don't get it.
All flat earthers are geocentrists by definition, but most geocentrists are not flat earthers.
So you're saying historically that the geocentrists didn't usually believe in a flat Earth?
No.
See, that's another one of those
in
misunderstandings.
the 700s said the Earth is round like a ball. I mean, come on. Everybody knew it. In fact, Eratosthenes, 200 or 300 BC, one of my favorite scientists ever. He was actually the head librarian at the Library of Alexandria, one of the seven wonders of the ancient world. And his hometown apparently was in a place called Syene. We call it Aswan today. And he had a pretty good estimation of how far away it was. And he knew that there was a well in Aswan where one day of the year the sun hit the bottom, which means right angle. The sun is straight up. So in Alexandria, he measures the angle of the sun. It was like 7 degrees. He said, oh, I'm 7/360ths of the way around the earth from that well. And if he knew the distance, he could use, old-fashioned Greek mathematics about, the circumference of a circle, and he figured out the circumference of the earth.
This is why Bede could also say that the earth was at least rounded in 700 AD.
Yeah. And this is why Columbus knew the earth was round. That was,
Thanks to a guy 200 years before the time of Christ.
Yeah. So everyone essentially knew the roundness of the earth, but we did struggle for a long time with if the earth moved or not, and we really didn't know it until the 1800s.
So what were some of was there anyone who ever came up with another stranger hypothesis besides geocentrism throughout history?
Like Big Bang?
Debunked.
Just a little aside here. The Big Bang model, a lot of Christians accept the Big Bang model. I know that. Some people try to blend the Big Bang with creation. God said it and bang. It's not right. It's not good. They don't mix like that. But I've heard this a lot.
That's not very good science or Bible.
No, it's not. Well, one of the issues with the Big Bang, the original model starting in like the 50s or something like that, when they finally conceptualized it, was just the universe started real small and expanded. But that didn't explain the data. And so Alan Guth in the 1970s, he comes up with what's called the inflationary model of the Big Bang. That is, the universe starts expanding, and all of a sudden, it expands like 10 to the 100th times in size in 1/quintillionth of a femtosecond. That's the real number. It took me forever to figure that out. Yeah, but expands massively in size in the smallest possible time increment you can imagine. You can't measure anything that fast. And then that explained more of the data. And I say it that way, I'm making you giggle on purpose, because when you say it that way, you realize...
I mean, that's an honest giggle, because I've never heard that before. And why would a scientist...
Because he's trying to explain
buy
data.
that?
And it does.
Wow.
It explains more of the data if you do that, but there's no physics behind it.
That's not scientific.
There's no reason...
I'm not a scientist, and I know that.
There's no reason for the expansion to start when it did, or to stop when it did, or to grow by the amount that it did.
No,
That's
nothing expands like that.
Yeah, and it's not physics. It's a magic wand.
Yeah. Well, even magic has, I mean, if you're using Harry Potter standards, has
There.
more sense than that.
Only if you put it in those terms. And yet, what else is there? What are you going to do? Turn to creationism? That God did it? That makes a lot of people really uncomfortable. So they hold on to this thing that's, honestly, it's not intellectually tenable, but there's nothing else. And hopefully that they're thinking, well, we'll find the physics, we'll discover the smoking gun that really demonstrates it and whatnot. But it doesn't work that way.
So you bringing up God, that reminds me that some people have said that the Bible supports the flat earth theory or geocentrism. Why did people say that, and is it true?
It is not true. However...
You're just saying that.
No, I'm not saying that. The Bible's not a science book. The Bible is a book about the history of the bride of Christ. God created this universe.
So you're not using it as a scientific textbook. You're not supporting geokinetic theory by saying that it is in the Bible. You know, that's extra biblical.
It's not necessarily extra biblical. There are a couple of verses that do support it. But if you're standing on earth and you're talking about things, you can talk about sunrise, you can talk about sunset.
Mm-hmm. Yeah.
Because you're not going to say, oh, the earth is rotated in such a way that the line of sight of the sun to my eyeball is no longer eclipsed by the curvature of the earth.
Yeah, even
don't say
scientists
that.
don't talk like that.
No one talks like that. It's sunrise. And so there is, in the Bible, it's just descriptive language. Simple descriptive language that everyone uses every day. It's not wrong. It's not scientifically wrong, but it's not meant to tell us about nuclear physics. It's not meant to tell us about the speed of light. It's not meant to say, oh, the earth is fixed and unmoving. It's not true. A lot of people say, oh, but it says that the earth is fixed. Yeah, well, you know what? It also says that the psalmist's foot is fixed and cannot be moved. No, that means that he's righteous and he's not going to sin. And so you have to put things in the proper context, in the proper grammatical and historical context.
So this actually sparked a thought. Geocentrism was the popular theory for thousands of years.
Absolutely.
We had sacred texts. We had the birth of Christianity 2,000 years ago. But geocentrism wasn't debunked until 500 years ago. So that was 1,500 years of geocentrism popularized around the world for anyone who ever gave it any thought. Why did the biblical language kind of keep geocentrism going on artificially?
Actually, no. I think it was Greek philosophy. The Ptolemaic model. Ptolemy was a astronomer back in ancient times, and Aristotle was incredibly influential, and the scholars had a hard time divorcing themselves from literally pagan philosophers, and it was intruding upon biblical studies.
Well, there was a melting pot of culture because of the influence of the Roman Empire for a long time.
Yeah.
I remember because just playing empire-related games like Age of Empires, using the Byzantine Empire and realizing that they were an offshoot and the descendants, the remnants of the Roman Empire, that a lot of these ideas just got perpetuated. And I remember listening to just this YouTuber the other day who was saying, how did we get here? Why do we believe the things that we believe. Why is America as a government the way it is today? Because of the decisions that were decided on, made up, 200 years ago, 400 years ago. That is what has happened a lot of the time throughout history. A lot of the reasons that certain scientific theories were not debunked earlier was because of the melting pot of culture.
A lot of the American ideas of law and freedom come from the promises made to the barons that came with William the Conqueror to England. And because he made them promises, a couple hundred years later, we got the Magna Carta, where they forced the king to obey the promises that they had been made to them. And boom, 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 we got the American Constitution. That's a long time ago.
Who thinks about that? I mean,
I do.
Man. Yeah, the historical buffs.
So going back to summarize this idea, yes, most people in history thought that the sun went around the earth. This is true. The pagans taught that very adamantly, and most people believe this. Okay, it is not anti-biblical to say that the earth goes around the sun. It is certainly not anti-scientific to say the earth goes around the sun. It's not a pagan idea. It's not like, we're worshiping the sun by saying the earth goes around the sun, because the pagans thought the opposite. In fact, one of the ideas way back when was that the closer to the center you got, the worse things were. So the heavens were perfect, the earth was corrupt, and hell was in the middle of the earth, you see. Well, by making the earth move around the sun, now the sun's at the center. It was actually putting earth in a more perfect position than it was earlier, according to this philosophical school.
Ooh, that change. Oh, yeah, that changes a lot. If you start with the other notions.
So it's not paganism. It's actually a triumph of Christian thought that's coming out through experimental science. And it's a triumph of the human mind. And also, it is God honoring to study the heavens. If God made the heavens, we can study them. For people that are thinking now, I've never heard anything like this before, or you're nuts, or anything like that, Dr. Jonathan Sarfati and I have written a very comprehensive article. I think it started out as 32 pages on Word before we loaded it up onto creation.com, and it is it's gotten only bigger since then as we come up with new ideas and fun ideas to explain why the earth goes around the sun. It's called Refuting Geocentrism. We also have a couple little videos and things. It's all be in the show notes for interested people to click on and watch and learn and listen. Because you know what? Learning's fun.
Oh, yeah. I'm just enjoying the fact that I get to revisit all these science subjects. I enjoy science as a subject, but a lot of the time I haven't made time for it in my adult life. I'm rediscovering it along the way.
Cool. Well, I'm glad you are. Hopefully someone else is also.
So if you have any questions about geocentrism and the subjects that we have discussed today, you can share those questions with us on Twitter. You can send us a tweet. Our handle is @podcastequinox. And if you want to get a hold of Rob, you can find him on Facebook. His webpage is called
Biblical Genetics.
And if you want to get a hold of Rob on Twitter, what is that handle now?
Bible Genetics. Yep.
Okay. I'm JCS Darnell on Twitter. And
Joe, I love doing this with you. This is our second one. This is a lot of fun. I love the conversation.
Yeah, me too.
And so you listeners, stay tuned for our next amazing conversation. You have no idea what we're going to talk about. We do, but you don't.
Exactly. All right. Until next time.
This is Equinox.
Thanks for listening.